electromagnetic induction. Yes, the topic which has lot of dimensions. Especially children find so many difficulties in this chapter. So I have taken this challenge to explain this chapter, numericals especially, in next 20 minutes that you will be able to do numericals on this chapter. I can challenge you. Please do write in comment box if you are able to do so. So here first I need formula sheet. Whenever we think of numerical children, make a small formula sheet, maybe kind of flow chart, maybe you have written all the formulae together. So that is the first thing you have to do. Make your formula sheet. So in this chapter, everything is about induced current. I want to get induced current. To get induced current, most important thing which we have to change is magnetic flux. So first thing here, I must know magnetic flux. Flux is AB cos theta. And what is that? Before starting about numericals, I will keep updating you what you have learned in this chapter. Suppose this is a plane. Area we take perpendicular to the plane always. Direction of area vector is perpendicular to the plane. It could be outward or inward if it is a surface, two dimension. Unlike in Gauss theorem, you take a closed surface. So conventionally we take area vector perpendicular and outward. Here it should not be like that. Need not to be like that. Any surface, let's say this my palm is a surface. So area vector is perpendicular to the surface. The moment I have a different position of my palm, area vector direction changes. So in that case, what I have shown you, magnetic field is this way, left to right, and I am holding my palm in this way. So there is an angle between magnetic field. Suppose the magnetic field is in this direction. So right now the angle between magnetic field and area vector, this is area vector and this is magnetic field. Parallel. So what is the angle? Correct, 0. But I am not showing you like this, I am showing you this way. So there is an angle between area vector and magnetic field. So make sure theta is very important. You should be identifying it. Any surface you take, suppose this board is a surface. So area vector is perpendicular outward or inward, my choice. I can take outward, I can take inward depending on the question to question. There is one thing which is area is always perpendicular to surface. B is magnetic field, A is area vector, and magnetic flux we give as phi. If you can change phi, again I repeat, if you can change phi, you can get induced EMF. So that is given by Lenz rule and Faraday rule. So Faraday Lenz, they have given a rule which says induced EMF E equal minus d phi by dt, and if the coil has n number of turns, we put n there. N is the total number of turns. The coil has how many turns? So E equal minus n d phi by dt, where what is E called? E is what? E is induced EMF. E induced EMF minus n d phi by dt, n is number of turns. If I can change flux, I will be getting induced EMF. But how to change flux? Flux I can change by changing area, by changing magnetic field, or by changing the angle. But one more thing we know, most of the chapters which you learn in 10th and 12th regarding magnetism, you have seen the magnetic field depends on current. Current, which current? Conventional current which we get from battery. So any current which comes from cell or battery, we say conventional current. So if I change the current, I can change the magnetic field, and we know that both of them are direct proportional. So magnetic field is directly proportional to height. Keep in your brain. So if I want to change the flux, first area, second magnetic field, third angle between A and B, fourth current, conduction current or conventional current. So again, changing the flux, correct, magnetic field, very good, area vector, angle between B and A, and conduction current. If I can change one of them, there will be induced EMF. And if the circuit is closed, induced current will be there. Induced EMF, there is a minus sign which shows the opposing nature, as I discussed in my first video about Lenz's rule, how we apply, how we get direction of induced current. Those who have not seen, please see that video. That will help you out to know the direction of induced current in seconds. Here I am taking a bigger challenge. I have got requests from many students, numericals are not our cup of tea. I said, why? क्यों नहीं कर सकते numericals? We can, because numericals are the most easiest part. How? If you know some kind of technique. That technique I am disclosing in front of you. Induced EMF. Now induced EMF, as I said, I can change magnetic field, I can change area, I can change angle, or I can change current. So depending on number of situations, you will have different kind of induced EMF. I am going to give a small list. With that flow chart, we will link with the numericals given in reader, and then you will see that it's very simple. Okay, coming to the formula sheet, as I said, induced EMF, again, induced EMF, I am further dividing into number of branches. Number of branches means flow chart. First we say motional EMF. Motional EMF, LVB. What does motional EMF means? Motion means movement of conductor. Movement of conductor, motional EMF. Suppose this arm PQ is moving with velocity in a uniform magnetic field. The symbol you know, magnetic field is perpendicular and inward, and arm PQ is moving with velocity V, and the length of arm is L. V and B are always perpendicular when you apply this formula. Velocity and magnetic field will always be perpendicular whenever you apply this. Then only there is a change in magnetic flux and induced EMF will be there. So whenever I move this arm PQ with velocity V in a uniform magnetic field B, the induced EMF will be LVB. In case of Earth, we have got two components, horizontal and vertical, and there is a dip angle, but this year onwards, Earth's magnetism they have removed. So we need not to do that kind of questions. But again, there also V and B should be perpendicular. So first equation keep in your mind, if a conductor is moving, I am going to apply motional EMF. This equation is there. This is a general equation which gives the entire chapter explanation. But I am giving you topic wise different cases which the formula you remember, apply and get marks. Second, which I am going to give you, self. In self-induction we have phi equal Li and induced EMF equal minus L di by dt. Because when I substitute phi Li, I get this. Since induced EMF is minus N d phi by dt, or if it's a one turn, we can relate and get the equation for that also. So this is self-induction, induced EMF, then we have a mutual induction. In mutual induction, we have phi MI1. Mutual. What does mutual means? And what does self means? When you get your answer sheet, you open that, you see that, अरे ये तो मैंने mistake करी है. This is done by me. And you understand your mistake. That is self. Mutual induction, let me give an example. You saw your answers, but you are not able to find out your mistake. Then what you do? You approach to your teacher. Then teacher explains you क्या mistake आपने करी है, what mistake you have done. So that is called mutual induction. So here, similarly, when there is an induced EMF in a coil itself, whenever there is an induced EMF in a coil itself by change of magnetic flux, that is called self. But if there is an induced EMF in a coil due to change in current in neighboring coil, suppose there are two coils, I am changing the conduction current here by turning off the battery or turning it on, current increasing, current decreasing. So there is a induced EMF in the neighboring coil, like in transformer. If you have red transformer, you know that I am changing the induced current, I am changing the current in one coil, getting induced current in another coil. So we are changing the magnetic flux in transformer. Basically we are changing the magnetic flux and we are getting the induced current. So here mutual induction, so current is flowing in one coil, magnetic flux linked with the another coil. So phi 2 equal MI1. Each topic, and this is from my side children, those who are watching this, any topic of class 12 where you find not easy, very difficult for you, do write in comment section. I will make it easy for you. I will try my level best so that you can understand easily. So we have got 1, 2, 3. Two more I am going to give you. Rotation of a conducting rod in uniform magnetic field. This is a conducting rod, let us understand. A conducting rod is pivoted here and is rotating. Especially these questions you can identify with the spokes of a cycle. In a bicycle there are number of spokes, and when the rim of the cycle rotates, this spokes also rotates. Suppose you rotate the spokes in a magnetic field which is perpendicular to the spoke, then they cut the magnetic field lines. Suppose these are magnetic field lines and I am rotating this, so it cuts the magnetic field lines. And when you cut magnetic field lines, there is a change in flux. Change in flux means induced current and induced EMF. So in case when you are rotating a rod, we get induced EMF. And that formula is E equal, oh I forgot to write here, induced EMF for this case, E2 equal minus M dI1 by dt. Here it will be half B omega L square, where omega is 2 pi nu. Omega is 2 pi nu. But if it is not a rod, right, I'm talking about a rotation of a rod. But if I don't talk about rod, if I talk about a coil rotating in a uniform magnetic field, a coil rotating AC generator, the topic in your reader must have come across in class 10, but I don't know in COVID situation. You have read that or no? AC generator is the last which I am going to give you here. AC generator. In AC generator, rotation of a coil in magnetic field. Rotation of a coil in magnetic field. In that what we have? E equal E naught sine omega t, where E naught is the maximum EMF NAB omega. You can remember Ben omega. You can remember Ben omega or NAB omega, maximum induced EMF. So here what I have given you, children, look carefully. These equations, remember, if you know the situation and the formula, I can challenge you, you can do any question of chapter 6 EMI. What we have, first main equation of this chapter. You know, when you go and watch a movie, there is a hero. The story roams around it. The story moves around the hero. In my chapter, hero of this chapter, EMI, is Faraday's law. Faraday's law of EMI. E equal minus d phi by dt. Where if you change flux, induced current will be there. Now changing flux could be changing magnetic field, changing area, changing current, changing angle between B and A. And you can get induced EMF. That situation you have to identify what you are changing. In the case 1, motional EMF. Suppose this conductor I drop is not rotating, is going down, is falling in Earth's magnetic field. Earth, as I told you, has vertical component and horizontal component. So when this rod falls, it cuts magnetic field which are horizontal direction, and there is an induced EMF across the rod. So induced EMF, whenever there is a motion, remember, whenever velocity given, LVB, induced EMF, LVB. Self and mutual inductance you will come to know directly. In the question written over there, self-induction or mutual inductions, anything, you can easily catch them. E equal minus L di by dt or minus M di by dt. Minus you can avoid when you find magnitude of EMF, especially in numerical. Then comes to rotation of a rod. Rotation is a rod, rotation. Half B omega L square. And last but not the least, AC generator. E equal E naught sin omega t, where E naught is bend omega. Omega is angular frequency or angular velocity, which is 2 pi by nu. 2 pi by t or 2 pi nu. So these are the equations. Look a question in NCERT reader which I am going to write here for you, because as you know I don't have space over there to write much. I will rub them. I will write the equation one corner. You have to identify equation 1, 2, 3, 4 or 5. 1, 2, 3, 4, 5, and the sixth one is the major equation. One of the equation we will apply to get induced EMF, and if they ask current, current is Ohm's law, E by R, because induced EMF is E. Ohm's law is I equal V by R. Instead of V, we have induced EMF E. That's all. Numericals going to be very simple for you if you remember these equations. So I'm just giving a pause right now to note down these equations. Please note down this, and then we will get back to the numericals from reader. Formula, children, I have written again for numericals. Out of this 6 equations which I gave you detailed idea, identify which one I am going to use. I have written question in short format which says current in a circuit falls from 5 ampere to 0 ampere. Current is decreasing. This is conduction current or conventional current. This conventional current decreases, flux changes, induced EMF is there. How much time it takes to decrease? 0.1 second. If induced EMF is 200 volt, find self-inductance. I have changed the question language, it's the same thing written over there. You have to find self-inductance, which in this equation we have self-inductance. The symbol is L. Self-inductance symbol is L. So if you identify, these are my tools. Correct? Yes, you are guessing correct. Equation number 3. So equation 3 I am going to apply E equal minus L di by dt. Very good. Now in this equation, children, I need induced EMF to get L. This is the question mark here. To get L, what I need? A few parameters. Induced EMF. Induced EMF is given to us. Yes, 200 volt. Di. Di means change in current. So current final is 0, initial is 5. So 0 minus 5 gives me minus 5 ampere, and it takes 0.1 second. all these in SI. Make sure you, whenever you write, all the data given to you should be in SI unit. Now I have got E, I have got DI, I have got DT, calculation of L. Physics over, mathematics started. Calculation under mathematics. Physicists only need to apply their brain to get formula. So simple. Now substitute 200 equal minus L minus 5 divided by 0.1, which we can write 10 to the power minus 1 second. So minus get cancelled. 200 equal 50 L or L equal 4 Henry. Calculation 200 by 50. 2 marks straight away in your pocket. Very simple, direct question and frequently asked in board. Hope you understood how to apply. Maybe slowly you are understanding it. I got it. You got only 50% right now. Don't worry. Think again, watch this video. What I have said, some important points keep in your brain. I am sure you will be 100% confident in numericals. This is one numerical. I am going to take the second numerical now. You can copy by the time we will go for the second one. Children, next numerical is same I have taken, but what I did, modification. That's what CBSE does. They take the numerical, they just change here and there or something, and they just do the modification. Modification why they do? To check whether you really apply your brain or no. If you just memorize, never good for physics. Understand, you will be getting it better. So what I modified here, which the same numerical I changed, and now I ask you find the change in flux. Find the change in flux. Question is same, little modification I did, which frequently asked in board. So you need not to scare about it. You keep your mind cool. Think, I have got one catchy word here, self-inductance, which I did in the first part. What was the formula I used? E equal minus L di by dt. I have applied this equation, right? But now my aim is to get change in flux, d phi. There is no d phi here. Yes, there is no d phi. But I have got equation for E. First equation. N is not given in the question, right? Suppose N is not given. It's just a loop. So then I will use E equal what? Minus d phi by dt. N is not given, suppose. There is only one loop they have said. So E equal how much? Minus d phi by dt. If there are 10 number of turns, then E equal minus 10 d phi by dt. N is not there, so N I will not write. Minus d phi by dt equal minus L di by dt. Dt get cancelled, minus get cancelled. So d phi equal L into di, 4 into the change in current is 5 in magnitude, so 20 Weber. How much is the change in flux? 20 Weber. So flux decreases in that much, or change of flux is 20 Weber, you can say. Over. Step by step, relate one equation to another. That much you have to do. Once you get this touch, how to do, once you get the nerve of question, and every question, children, there will be some catchy word I say. Catchy word means gives me a quick idea which equation I am supposed to apply. This is one of them. I am going to take arbitrary one more question there. You have to tell me which equation should I apply. Okay? By the time you copy this. So children, this is another question I am taking it on EMI. Always remember again, some words will be there which will give you idea numerically is based on what topic. If you are able to find out, it will be very easy for you. And according to new CBSE scheme, new sample paper, if you go through it, hardly there are derivations. So you can't rely on derivations. You have to understand question, you have to apply, analyze and get answer. Things are not getting difficult, things are getting easier. Why? Because you can understand now numericals. In doing the same way, I have taken another numerical of reader. Page number might differ. I have an old reader. You might have a new one maybe. But unsolved question 6.6 will be same. I have written some catchy words, not exactly the line of reader. What it says, there is a coil. There is a coil which is rotating. Coil is rotating. Now this coil is rotated. With this itself, I should know which one I am supposed to apply for induced EMF. Because I have to calculate maximum and induced EMF. And you know what is E naught called? Maximum induced EMF. And this equation belongs to AC generator where we can rotate a coil. Coil could be circular, coil could be rectangle, square, anything. So with this word only, circular coil is rotated, immediately my mind thinks of equation 6, which is AC generator. And then they are asking maximum EMF. The maximum EMF formula is what, children? NAB omega or Ben omega, whatever way you can remember it. Ben omega or NAB omega. I got equation for maximum EMF, but do have all the data with me. Are data given to me or no? So let us see. N, number of turns. Number of turns given 20. N equal 20 turns. A, area. Circle. What is the area of a circle? Right, pi r square. So area of a circle is pi r square. But to calculate area, I need radius. How much is the radius given? 8 centimeter, which is in meter, 8 into 10 power minus 2 meter. Convert there itself in meter. Centimeter to meter. Then I need B, magnetic field, which is given to us 3 into 10 power minus 2 Tesla. And omega also they have given us 50 radian per second. Everything is given to me. I have to plug in this equation, get marks, live happily. Again I say, identify some catchy words. Think of the one of the equations which I have written. You will be seeing that you can get almost all the numericals now. If you understand the question properly, what they are asking, what equation I am supposed to apply, and you will see that is easy. Numericals are getting easier and easier for me. And that I need this feedback. If you have that feeling, EMI is getting one of your favorite chapters, please do write in comment section. Now what they have asked further? Average and maximum and average induced EMF. Sorry, I missed out the word here. Maximum and average. Average, whenever we talk about a closed cycle. So if you have seen the graph, EMF was like this, changing, and this is called one complete cycle. So during the first cycle it is positive, then negative. So average induced EMF equals 0 for one complete cycle. For one complete cycle, average induced EMF will be 0. And that kind of question, 0 volt. Yes, I forgot to write unit. Whenever we write any physical quantity, we must write unit. Though it is 0, but it has come from, gives us an idea that we are talking about induced EMF. If I write 0 meter, I am talking about distance. If I write 0 Newton, I am talking about force. So induced EMF is 0 volt for one complete cycle. Further modification, they ask current. Ohm's law, you know, I equal V by R. So current will be EMF E by R, and R will be given to you. If you read the numerical carefully, below 2 lines, they must have given resistance R. You can calculate current E by R. Power loss I square R. Everything we can calculate one after the other. So here, equation 6, how to use. Hope you understood that. One more numericals I am going to take. You tell me whether you can do or not. Okay? Let's see one more numerical. Another numerical. Again from your reader. 6.7. Horizontal straight wire. Wire is made up of what, children? Copper, aluminium, iron. So it's a conductor. So a straight wire. Now what is happening to it? It's extended from east to west, north, south, east, west, we know. It's falling with a speed 5 meters per second. Suppose this is a wire. East, west, and this wire is falling. I told you Earth's magnetic field horizontal and vertical. So it doesn't cut vertical lines, but horizontal magnetic field it will cut. So therefore, when wire falls through magnetic field, it cuts which lines? Horizontal magnetic field of Earth. Therefore, what equation I am supposed to apply to get induced EMF? Wire is falling. So is a motion in a conductor. Wire is a conductor. Motion in a conductor means motional EMF. And motional EMF, equation number 2, LVB. That's how we apply. A wire, whenever it moves with some velocity given, and induced EMF, LVB. So direct question here, induced EMF, LVB. But B is horizontal component. Vertical component has no role because wire doesn't cut magnetic field lines in vertical direction. Only horizontal direction it cuts the magnetic field. So what is the equation? LVBH. Now nothing else. L given to us. L 10 meter. Speed of wire 5 meter per second. And BH 0.3 into 10 to the power minus 4. Generally we write Tesla, but this is another unit of Weber per meter square is another unit of magnetic field, and we can keep these values, substitute. When you plug all these values in, you will get marks after solving them. So plug these values in, simplify, get your answer in volt, question is done. Hope you are enjoying now doing these questions. Do many questions of this chapter. If still you have a doubt in a particular question and you can't understand that, please write me in comment section. I will help you out. But the whole chapter roams around main equation minus d phi by dt, which is Faraday-Lenz rule, and these equations will help us to do numerical in fraction of seconds. So I believe if you remember them, you can apply easily. And do let me know any topic which you feel very difficult for you. I will try to make easy for you. Thank you. Have a nice day. Bye-bye.